How do F1 engines achieve over 50% thermal efficiency? Imagine an engine that turns more than half of the fuel's energy directly into motion. That's what F1 engines are capable of doing. It's like squeezing every bit of juice out of a lemon. These engines are not just powerful, they are also incredibly efficient, thanks to a mix of smart engineering and innovative technology. First, let's talk about how they burn fuel. F1 engines operate at extremely high temperatures, around 2600 degrees Celsius. To handle these intense conditions, teams use special materials and coatings inside the engine that reduce heat loss and friction. This means less energy is wasted on unnecessary heat or mechanical resistance. Over the years, this focus on materials has pushed efficiency from about 29% in older V8 engines to nearly 46% before hybrid systems came into play. Now, the real game changer is the hybrid system. Since 2014, F1 cars have combined a turbocharged 1.6-liter V6 internal combustion engine with electric motor generators. These electric parts recover energy that would normally be lost. For example, the motor generator unit kinetic captures energy from braking, and the motor generator unit, heat, recovers energy from the turbocharger's exhaust gases. This recovered energy is then stored and reused to give the engine a boost when needed. This recycling of energy makes the entire power unit more efficient and helps push the thermal efficiency over 50%. Another important factor is fuel management. F1 rules limit fuel flow to 100 kilograms per hour and total fuel used during a race. This forces teams to get the most out of every drop of fuel, encouraging smarter combustion and engine control. They fine-tune everything from ignition timing to fuel mixture to squeeze maximum power without wasting fuel. Cooling and aerodynamics also play a role. Efficient cooling systems keep the engine running at optimal temperatures without needing large radiators that cause drag. Better aerodynamics reduce air resistance, which means less energy is wasted overcoming air friction. This indirectly helps the engine stay efficient because it doesn't have to work harder to push the car forward. Finally, continuous innovation is key. Teams constantly improve engine oils, electrical components, and cooling systems. Small upgrades like better inverter materials or cooling rotors cut electrical and thermal losses. These incremental improvements add up, making the engines more efficient over time. In the end, these advances mean F1 power units produce about 20% more power than older V8 engines while emitting much less carbon dioxide. The combination of advanced combustion, hybrid energy recovery, and strict regulations has created engines that are not only fast but also remarkably efficient. This technology is not just for racing. It influences how cars are built for everyday use, pushing the automotive industry toward cleaner, more efficient engines.